Hi, I'm Tim Sinclair Pearce of QMRE. We are Biofabrik's UK and Airs distributor and operator of equipment here in the southeast of England. We constructed this site to show the P250 in the background there, and this site was set up with an office and containers as in a compound, specifically to demo the P250 Biofabrik machinery. To give you an idea of what we're doing here specifically, we have a store container here which has polyolefins inside, predominantly PP and LDPE, which are in this particular case quite clean, but of mixed variety and thicknesses. They are quite clean, specifically because we are setting a benchmark for the initial fuels we're producing. However, we can take contaminated stock to a very low degree for demonstration purposes, but in the real world we will be able to clean and dry certain other stocks. We would normally bring the stocks to the machine in a format of which my colleague here, Mark, is just about to demonstrate. In normal circumstances, in the larger machinery, these would go in bales, but these are being hand put into the machine, hand sorted and put in just to size reduce them to give a demonstration. As it happens, the machine already has some stock in it, but we'll feed a little bit more through to show you how the system works. The size reduction equipment will take the material down to the size of a coin. It'll be fed through this vacuum cable and into the silo. To give you an idea of what it looks like inside the silo, because it's not so easy to see, here's something we prepared a bit earlier. You can see it's a bit of a jazz of different colours of plastic. Again, the difficult type of product to handle for most people are the soft plastics. So these soft materials, having been size reduced, pass through the vacuum pipe up and over the top into the day silo. The day silo is usually filled in the morning and at night. This one would probably carry about 125 kilos of each, and you can see the small items of plastic flying around inside, and they are agitated by the agitator inside, which will basically move to push the cut plastic down through a section in one corner and drop through this funnel section and to the screw which is off to the left hand side. And as you can see here, the Archimedes screw is propelling the size reduced material up to the top and in towards the unit where it drops again into a stuffer unit. This process is computer controlled, and the machine will automatically know when it has enough, and the stuffer system here will tell it to switch off and wait until it actually needs any more. The stuffer is flattening the material and pushing it into the extruder. The extruder is running at around 200 degrees, and that basically is making the product into a bubblegum constituency, so it's a bit putty-like by the time it's pushed in here, so that it's not too small to go into the thermal kettle reactor. It needs to have some consistency to it, so it goes from these small particles here. It's heated as a preparation into a putty form, and then it's pushed into the reactor, and these sensors are giving us information about the whole process. Inside the reactor, which we call a thermal kettle, there's another Archimedes screw, and the Archimedes screw, by the time it gets about halfway up here, goes from a solid Archimedes screw into a skeletal format, and that's because when we get towards the top of the process, we're already creating gases. The heat within the process this is quite a unique process, because most was done with a kettle with like a drum. This is actually a tube, and these are electronic gauntlets around the outside of the thermal kettle. Nobody else does it like this apart from Biofabrik, and the temperatures running in each of these gauntlets is probably between about 450 degrees up to about 500 degrees when we get to the top. The sensors on the side of the machine give us all the information, and that's fed over to computer systems. The separator is here, and this is where a lot of the magic happens, because we have the tower is basically where the gases are forming, and we have different levels of gas and different thicknesses. The thinnest of them all is at the top, and that's the lightest fraction is the one that we draw off to run the machine. The heavier fractions are inside the tower, and towards the bottom here, the heaviest fraction would be what we call carbon ash. This is the waste product, and in this case it's manually detached, but in the case of a P5000 it's a fully automated system. So within the tower, once the tower starts to send materials through and gases through, they're taken into these cooling towers, and the cooling towers basically are fed through cooling radiators of this type. They actually cool the sections and send the information back to make sure that the gases are turning back into solids effectively as a liquid, because they're being cooled. We've got two of those, and one at the front of the machine and one at the back. So we come back round and out of the machine. I can show you around the other side. We can have a glance at the end of the machine here to see that the stuffer is still working, and then inside here the gas that we're taking off, the lightest fraction, is coming out of this stainless steel pipe and off the top of the system. We're not using that we cannot turn that back into a liquid, so that goes off in this pipe and goes over to the genset. We'll come back to that in a minute. So you can still see the stuffers sending raw material into the extruder, and on the left you can see the reactor is moving slowly, but the movement appears slow, but you can actually see it, and at that speed it's still moving 250 kilos per day. So if we come round this side, you can see the other side of the cooling towers, and the pumps which are feeding the what is now a liquid around these pipes. The pipes are trying to keep the product at a reasonable temperature. We want to cool it, but we don't want to cool it too quickly. So it's all being measured, and we can, if we wish, at this point, we can draw off some samples, which we will do in a moment, from that tap. This is the Siemens Biofabrik computer system, and it gives us a vast amount of information every day. More importantly than just in this environment inside the container, we also have the benefit that in our office we'll have this on our computer systems, and the operator will also have it on his phone or iPad. We're just changing over to show you another screen, which is the startup section of the system. and so you can see here to the left hand side in the middle the extruder, and the temperatures at around 200 in the middle, and then in the central section the thermal kettle, the reactor, is 430, 429, 463, 459, and they're the sections of the reactor. And then we've got the separating system, as you can see, at 594 degrees. One of the cooling towers is shown there as well on the right hand side, which is, I think, is around about 106 degrees as I can see it there. So if we come back out of here for a second, I think we'll just ask Steve if he could give us a demonstration of some oil coming out. So here we go. I think we will be ready in a second to show you from the tap on the left hand side here that it's like a bleed tap. He's just changing the settings so that we can shut some of the pipe work above it down a bit, but now, as you can see, we can let some of the oil out of the system. So what we actually saw a few moments ago going in as particles of plastic jazz have now actually gone into the system through reactors, through the coolers and separators, and back into an oil. So the gas from the system is basically running over to the genset, and we can see the pipe work here on the floor. Is feeding that over to this section. This section basically is cleaning the gas. We're storing it in a small gas tank, and then we're cleaning the gas before we combust it in the genset. So the pipework then will take the gas back out through to into the inlet manifold of the genset, which is basically a diesel style genset, diesel generator, but we're feeding 50% gas in to the inlet manifold in this particular case. The interesting thing is from that we're actually getting a greater amount of power, closer to 70% from the gas and 30% diesel. But the important thing is that if you see on the top of the machine where the exhaust is, if you look over the top, the combustion of the system is such that we are getting less than 20% of emissions that we would normally get from diesel. And as you can see, over the P250 or anything around the P250, there is no emission whatsoever, and the power is all being supplied by the genset which you were just looking at. I think this is true to say this is unique and very clean. The outturn materials which we're producing in oils that Steve didn't take out in the sample pot are on the right there. They're going into the barrels. And just to run through that again, if we chose, we could obviously go a stage further than the clean materials that we have in the bowls on the floor there. We could, in fact, go one stage further back than the genset itself, and we could put in a further cleaning and size reduction unit and a cyclone to clean the plastic on the way in, if required, which would come in bales. We would be still generating our own power. We would then put that into a much larger size reduction unit there, which would still be that would probably be conveyor supplied, and then instead of the silo being inside the P250, it would probably be vertically fed over the top of each of the machines. This being a P250, but obviously we would they would be P1000s, and then off to the side we would have the offtake. Thank you for listening.